More than 70% of load-bearing applications rely on natural rubber, meaning this seemingly simple white latex is actually the lifeblood of an industry worth up to 35 billion USD. So how do humans transform millions of tons of raw rubber into a strategic material of modern industry? The journey begins in deep, emerald rubber forests, where farmers quietly tap millions of trees to collect streams of pure white latex. From there, the latex is transported to advanced processing plants, passing through a series of sophisticated steps to become one of the most durable, flexible, and elastic materials in the natural world. Today, join Agriculture Insight as we follow the path of these white drops, from the forest floor to industrial production lines, to understand why they have become the foundation of millions of products that surround us. Although natural rubber is now closely associated with Asia, its origins trace back to the dense Amazon rainforests. For centuries, indigenous peoples of Central and South America tapped the latex of Hevea brasiliensis to create waterproof coatings and everyday household items. But the global turning point came only after a covert smuggling of rubber seeds out of Brazil, an act that paved the way for the tree's introduction into Southeast Asia. Just a few decades later, the region rose to dominance, producing more than 90% of the world's supply, with Thailand leading the industry and exporting rubber worth billions of dollars each year. Natural rubber stands out for its exceptional elasticity, durability, and water resistance, making it an essential material for transportation, healthcare, and thousands of industrial products. Just 10 kilograms of fresh latex are enough to make a single car tire. But producing a latex mattress requires over 100 kilograms of latex, resulting in a material capable of withstanding pressure, many times a person's weight, and instantly returning to its original shape. And now, let me take you to Southeast Asia, a region with a humid tropical climate, fertile basalt soil, and year-round rainfall, all perfectly suited for rubber tree cultivation. Here, the trees are propagated using bud grafting. High-yield budwood from elite mother trees is grafted onto vigorous rootstocks that have been grown for 8–10 months. This ensures the next generation inherits the mother tree's superior genetics, a crucial factor behind durable plantations and exceptional yields. Young plants are placed in polybags, with soil packed firmly around the base to keep the stem stable. The natural outdoor environment helps them adapt early to sunlight, wind, and rain, reducing shock when they are finally transplanted into the field. After about 1 year, the young trees develop sturdier stems, their leaves darken, and the petioles begin to lignify, signaling that they are ready for planting. Unlike many other industrial crops, the most common cultivation model for natural rubber in Southeast Asia is the smallholder system. Each household typically owns only a few hectares of land, yet many have cultivated rubber for generations. Alongside these small holdings are vast plantations owned by state enterprises and private companies, spanning tens of thousands of hectares and managed under standardized, unified planting protocols. Every spacing measurement is carefully calculated. Nothing is done at random. In flat areas, rows are typically spaced about 6 meters apart. On sloped or moist terrain, spacing is reduced to 4 meters to limit erosion and make better use of shade. On average, each hectare contains 500 to 550 trees, dense enough for good canopy expansion, yet open enough to ensure strong root development for decades of tapping. Tapping latex is the most delicate and patience-demanding stage in the entire life cycle of a rubber tree. Before reaching this moment, the tree must undergo 6 to 7 years of continuous care, until its trunk reaches a circumference of 45 to 50 centimeters and a bark thickness of 6 to 8 millimeters, just mature enough to open its first tapping cut. In specialized farming regions, tappers begin their work quietly from midnight to dawn, when the air is cool and moist, and the latex becomes thicker, smoother, and flows most evenly. The latex vessels always run from upper right to lower left, so the tapping knife must be held at a precise 45-degree angle to follow the correct direction. Before tapping, workers mark 3 to 4 guiding lines using a pen and measuring tool, or press a plastic stencil against the bark to ensure perfect alignment of the cut. When the knife is drawn, its thin curved blade slices only about 1 millimeter deep, just enough to reach the latex vessels without touching the wood. A slight slip of the hand can cause the tree to bleed, dry out its latex vessels, or lose vigor. The latex drips into aluminum or corrosion-resistant plastic cups hung about 15 centimeters below the tapping cut, close enough to catch the entire flow, yet far enough to avoid contamination. After 4 to 6 hours, the cups fill and are collected into larger containers. Over time, the cups build up an oxidized rubber film, which must be cleaned regularly. A skilled tapper can work 400 to 500 trees in a single morning, the result of years of practice to master the rhythm of each stroke, the exact depth of the cut, and the distinctive snap sound of latex vessels being opened. Across southern Thailand, thousands of small factories work day and night to press fresh latex into latex sheets. Thin, pale, flexible, and resilient layers of rubber that carry the vitality of the tropical forest and serve as the foundation of the global rubber industry. As soon as the fresh latex arrives, it is roughly filtered and poured into large aluminum trays. Workers stir it thoroughly to disperse the latex particles, then add a formic acid solution, the catalyst that helps the latex coagulate quickly. Within just a few minutes, the liquid begins to solidify into a smooth, soft, milky white mass. The surface is carefully leveled to ensure uniform thickness before the block is removed from the mold. This marks the very first step in forming a complete latex sheet. Once the latex has coagulated, each sheet is removed and rinsed in a water tank to eliminate any remaining acid. The sheets are then fed through a rolling machine, 2 heavy steel rollers spinning in opposite directions that press the rubber flat and bring it to the correct thickness. With every pass, water and impurities are squeezed out, making the rubber clearer, more flexible, and more elastic. The fine mesh-like patterns that appear on the surface are the hallmark of a properly rolled latex sheet. After rolling, the wet sheets are hung outdoors to dry. Depending on the weather, this air-drying process takes 1 to 2 days. At this stage, the rubber has become strong enough to fold, roll, or move without tearing. The dried sheets are then moved into the smokehouse. Smoke from smoldering firewood or wood chips drifts through the chamber, both fully drying the sheets and tinting them with their signature amber color. This process also provides antibacterial protection, prevents mold, and enhances durability. When they step out of the smokehouse, each sheet has taken on a golden hue, flexible, tough, and ready to be baled for shipment. Once they reach the proper dryness, the latex sheets are pressed flat, graded, and bundled into neat, square bales. From there, they are sent to major factories, where these golden brown latex sheets will be transformed into tires, gloves, or durable shoe soles. All of them begin with a stream of white latex deep in the forest. Farewell to the smoky, wood-scented workshops. In modern factories, natural rubber latex is reborn as the core of some of the world's finest premium mattresses. Unlike memory foam, natural latex is inherently antibacterial, breathable, hypoallergenic, and offers outstanding elasticity and longevity. That's why, in the luxury segment, a king-size latex mattress can reach prices of up to $2,600 USD. First, natural latex is combined with various additives such as foaming agents, stabilizers, sulfur, and accelerators. This mixture is blended thoroughly in specialized mixers to ensure uniformity and achieve the desired physical and chemical properties. This step determines the mattress's elasticity, durability, and its ability to form a stable foam structure in the next stages. Next, the uniform latex mixture is poured into a specialized mold fitted with metal rods called pink-or pins, which create ventilation holes throughout the mattress. These holes enhance elasticity, airflow, and breathability, helping the mattress stay cool and comfortably supportive during use. Inside the vulcanization chamber, the latex mixture is heated and subjected to high pressure. The very breakthrough that gave birth to the modern rubber era more than 180 years ago. Heat and sulfur create cross-links between the polymer chains, transforming the soft, sticky liquid latex into a solid mass of elastic, stable, and durable rubber. Thanks to this process, the mattress core maintains its shape, resilience, and consistent foam structure for many years, a key requirement for it to qualify as a true industrial-grade product. When the process is complete, the mold is carefully opened after 1 to 2 hours of cooling. At this stage, the mattress is still soft and warm. Even a slight pull or a sudden impact can tear the surface, damage the ventilation hole structure, or cause deformation. For that reason, every movement must be slow, steady, and perfectly coordinated to ensure the mattress maintains its shape and surface integrity. After demolding, the mattress passes through a continuous, gentle washing system using clean water. Large rollers rotate slowly to turn and lightly press the latex block, allowing water to wash evenly across the surface while pushing out foam residue and impurities. This step ensures the mattress is not only thoroughly clean, but also safe, hypoallergenic, and user-friendly. The clean mattress then travels along a conveyor into a temperature-controlled drying chamber, which removes all remaining moisture, prevents mold growth, and preserves both the natural elasticity and stable foam structure. Before leaving the factory, each mattress is tested using an automatic pressure compression machine, a device capable of simulating tens of thousands of real-life sleep cycles. The machine repeatedly compresses and releases the mattress in a standardized rhythm, precisely measuring its sinkage, elasticity, and recovery ability. All data is recorded automatically. Only the products that pass this rigorous evaluation are approved for packaging and distribution. After passing inspection, the mattress is packaged with protective wrapping, vacuum sealed or rolled, depending on the model, then labeled, sealed, and shipped, ready to begin its journey to the consumer. In 2024, the global natural latex mattress market was estimated at about USD 10.6 billion, reflecting a growing demand for durable, sustainable, and high-quality sleep products. Leading brands like Avocado and Latex Co. have successfully embraced this trend, building their reputation on natural latex cores that are safe for health and deliver an exceptional sleeping experience. When it comes to toilet paper, there's probably nothing more fascinating, just like the thoughts running through your head when you suddenly run out. More than 2,000 years ago, before toilet paper existed, humans used all kinds of things to wipe. Stones, dry branches, corn cobs, even seashells. The ancient Greeks used small ceramic discs, while the Romans had a stick with a sponge on the end. Washed in salty water and shared by everyone in public baths. But countless ways to wipe. Humans have always been incredibly inventive when it comes to staying clean. It wasn't until the 6th century, in China, that toilet paper was first recorded, and it took over 1,000 more years before it became a household essential around the world. Today, the world produces more than 300 billion rolls of toilet paper every year, and this massive industry generates over $60 billion in global revenue. In the United States alone, the average person uses about 100 rolls per year, most of which are produced domestically. Familiar names like Charmin, Cottonelle, Scott, and Quilted Northern dominate the market, turning toilet paper into a true multi-billion-dollar business. And if you were at the supermarket, how would you choose your toilet paper? By brand, by the claims printed on the package, or simply by which roll feels right at first glance? And now, let me take you to the southeastern United States, where the subtropical climate and year-round rainfall have nurtured vast eucalyptus forests, meticulously planned and cultivated specifically for the paper industry. Each tree takes up to 20 years to mature. When the trunk reaches a diameter of 10 to 12 inches, with moisture below 60% and optimal cellulose content, it's ready for harvest. When the harvest season arrives, the forest comes alive. Massive harvester-forwarder machines, each weighing nearly 18 tons, move into action. First, hydraulic arms clamp the tree trunk tightly, while a chainsaw blade slices cleanly through the base in just seconds. The trunk is then lifted and fed through an automatic delimbing unit, where rotating rollers strip off branches and bark. Next, laser sensors determine the precise length and send data to the machine's control system. The log is automatically cut into even sections, roughly 2 meters long, the ideal size for transport and later pulp processing. The entire sequence takes only a few dozen seconds, requiring almost no human touch. Yet every move is tracked by GPS to ensure cutting stays within designated zones and avoids disturbing the forest floor or young roots. Even the machine's tracks are engineered to distribute weight evenly, preventing soil compaction and allowing the forest to recover quickly after harvesting. Most of the wood used for toilet paper is considered low-grade timber, crooked trunks, young cores, or blemished logs unfit for furniture making. Yet this very wood has the perfect balance of fibers and lignin for pulping. On average, 1 ton of eucalyptus can yield about 700 kilograms of paper pulp, and on an industrial scale, a single plantation like this can supply toilet paper for millions of people each year, all without touching a single natural forest. As the first trees fall, the next star of the forest takes the stage, the forwarder, a timber hauler capable of carrying up to 14 tons of logs in a single load. In other words, with just about 70 trips, more than 1,000 tree trunks can be transported to the collection site. Despite its massive, almost beast-like frame, the forwarder moves with surprising grace. With a hydraulic arm and a mechanical grapple that can rotate a full circle, it grips, lifts, and stacks bundles of logs weighing hundreds of pounds with precision, a mesmerizing mechanical dance in the heart of the forest. From here, the journey to transform those rough wooden trunks into soft white sheets of paper begins, as the green forest connects seamlessly to the mill through a transport network stretching for miles. When the timber trucks arrive, the journey begins anew in a very different way. Here, the logs enter the first stage of the paper-making industry. Thousands of tree trunks are unloaded onto vast yards spanning hundreds of hectares, where they are sorted, measured, and stacked into towering rows, forming walls of wood that mark the true beginning of their transformation. Every sheet of paper begins with pulp, but before it becomes pulp, each tree trunk must first be chipped into wood fragments, a process that seems simple but serves as the first true test of precision. Inside an industrial chipper weighing several tons, steel blades spinning at up to 700 revolutions per minute slice the logs into perfectly uniform wood chips, each measuring only about 2 to 3 centimeters in size. Here, uniformity is everything. If the chips are too large, the chemicals won't penetrate evenly. Too small, and the cellulose fibers will break apart. The entire operation is monitored by optical sensors, transforming what once seemed like a brute mechanical step into a fine display of technological precision. After that, the clean wood chips are pumped into a high-pressure digester, where a mixture of alkaline chemicals and heat breaks down the lignin, the natural glue that binds cellulose fibers together. Over roughly 3 hours of cooking, the lignin dissolves, leaving behind an ivory-white suspension of fibers, a thin, milky liquid that is, in fact, pulp. From a single batch of 25 tons of wood chips, the mill produces about 15 tons of high-quality pulp. The leftover black liquor, rich in dissolved lignin, is recovered and burned to generate energy for the mill itself, completing a closed-loop cycle of material and energy. The final step before this humble pulp begins its transformation into toilet paper. However, compared to virgin pulp, which consumes vast amounts of energy, water, and forest resources, recycled paper offers a far more sustainable path for the toilet paper industry. It can cut energy use by up to 50% and save 70% of water for every finished sheet produced. Yet, turning old paper into new material is no simple journey either. Recycled paper is collected from all kinds of places: offices, stores, printing houses, but not every sheet can make it back into the production cycle. At the mill, an automated sorting system takes on a task that seems simple, but demands incredible precision, separating paper from plastic, cardboard, metal, and debris. Using near-infrared sensors, the system scans each piece of paper to identify its material composition. And in a fraction of a second, bursts of compressed air blow away unwanted particles from the conveyor belt. Thanks to this technology, a single production line can handle up to 400 tons of recycled paper per day, creating a clean, consistent source of raw material, the foundation for everything that follows. Recycled paper, once sorted, is fed into an industrial shredding machine. Inside, counter-rotating steel blades pull the paper inward and tear it apart through continuous cutting, producing thousands of small uniform pieces just a few centimeters wide. The speed and spacing of the blades are automatically adjusted according to the paper's thickness and type. The entire process is enclosed, ensuring the paper is loosened and separated layer by layer, ready for the next stage of pulping and de-inking. After being shredded, the paper is sent to the processing area, where it enters a massive industrial washing system that runs through 14 continuous treatment stages. Here, layers of cellulose fibers are released from their original structure, ground into a fine pulp, and pass through multiple filtration screens to remove even the tiniest impurities. Next, the pulp moves into centrifugal cleaning chambers, spinning at extremely high speeds to separate heavier particles such as sand, metal fragments, or small pieces of wood. Though this process demands a significant amount of energy, it's still considered far greener than producing virgin pulp from wood, with each ton of recycled paper saving dozens of trees and thousands of liters of water. Even after cleaning, the pulp still carries the traces of its past, ink. To remove it, the pulp is mixed with a special soapy solution. As the mixture is stirred, countless tiny bubbles rise to the surface, lifting microscopic ink particles that cling to the foam. The dark froth is then skimmed away, leaving behind a cleaner, ivory-colored pulp beneath. Finally, the pulp undergoes a mild bleaching process and is diluted with water, forming a smooth, milky suspension, the purified pulp, ready to be reborn as paper once again. At the heart of this process stand massive machines over 120 meters long, running day and night, carrying out 4 remarkable stages of transformation that turn nothing more than water and cellulose fibers into paper. The pulp is diluted and pumped onto a continuously moving mesh belt known as the fourdrinier wire. As the slurry spreads evenly across the surface, water drains through the mesh, leaving behind a tightly interwoven network of cellulose fibers, the very first rough form of paper. At this stage, both the shape and strength of the sheet are determined. Even the slightest deviation here will leave its mark throughout the paper's entire lifespan, much like the foundation of a building. At this point, the paper sheet still contains dozens of times its weight in water. To remove this excess, it passes through a series of press rollers, each weighing several tons and operating under extreme pressure. As the sheet moves through, it is tightly compressed, forcing out moisture while strengthening the bonds between cellulose fibers. Continuing its journey, the wet paper sheet enters a system of massive heated drying cylinders, or long drying tunnels, stretching dozens of meters, where high temperatures evaporate the remaining moisture. Under the intense heat, the cellulose fibers contract and bond more tightly, forming a continuous sheet of dry paper that races forward at more than a mile per minute. This stage consumes the most energy, but it is also what determines the paper's whiteness, strength, and stability. Once it leaves the dryer, the paper still carries wrinkles and ripples caused by heat expansion and contraction. It then passes through a series of calendar rolls, where heat and pressure are precisely adjusted to smooth the surface, create a gentle sheen, and ensure uniform thickness. The result is a soft, even ribbon of paper, winding gracefully around the Yankee dryer drum, the final step before it's cut, embossed, and packaged. All of this happens in just 7 seconds, from a watery slurry to fully formed sheets of paper, light as air, yet born from hundreds of tons of force and thousands of sensors. After all that, the long sheets of paper stretching hundreds of meters are sent to the winding and cutting section, where the final shaping and packaging take place, turning them into finished products. Massive rewinding machines, each over 80 meters long, can process up to 500,000 rolls per day. The paper is then embossed with delicate micro-patterns, creating its signature dotted texture, a design that not only softens the surface, but also enhances thickness and absorbency. Once completed, the rolls are cut, wrapped, and packaged, ready to enter a global distribution network spanning more than 190 countries, where every day, billions of people begin and end their routines with this seemingly humble product. Bamboo is one of the fastest-growing renewable resources on Earth, capable of growing more than 30 centimeters in just one day, reaching maturity within 3 years, and regenerating without the need for replanting. Not only does it grow quickly, but bamboo also absorbs twice as much CO2 as many tree species, equivalent to 200 tons of carbon per hectare over 30 years, helping cut emissions and cool the planet. With all those benefits, it's no wonder even pandas can't resist bamboo. Across the tropical belt of Asia, particularly in China, India, Vietnam, and Indonesia, more than 35 million hectares of bamboo forests supply raw materials for a rapidly expanding global market. What truly makes bamboo remarkable is its versatility. Even today, it is still used as scaffolding in modern cities like Hong Kong, a testament to its extraordinary strength and flexibility. The rise of bamboo-based manufacturing is a completely new and rapidly growing global trend. It has now been divided into 2 main product lines: eco-friendly daily items, and durable industrial materials used in construction and energy. In China alone, the bamboo industry is worth over 40 billion USD annually, with bamboo forests tripling in area since 1950, while the United States and India have become the two largest consumer markets for these products. Beyond its industrial and commercial roles, bamboo also carries deep social significance. As a material that can be up to 70% cheaper than concrete or wood, it has literally saved millions of rural and low-income families, providing them with sustainable housing that protects them from floods and earthquakes. So, is bamboo truly the green material that's good for our planet? And how does it compare to plastic and paper? Every ending is a new beginning. And now, let's return to where every bamboo creation begins, the harvest season, where every bamboo product takes its first breath, as the sturdy stalks are chosen, cut, and readied for their remarkable rebirth. Harvesting more than 200 million tons of bamboo each year, with each stalk standing 6 to 10 times taller than an average adult, is no easy task. In the vast bamboo forests across Asia, harvesting takes place from October to March, the dry months when only 3 to 5-year-old bamboo is strong enough to be chosen for cutting. In industrial plantations, bamboo is usually cut horizontally with chainsaws, a fast, stable, and highly efficient method. However, bamboo stalks cut this way do not regrow, as only new shoots sprout from the underground rhizomes. If you look closely, you'll notice a key difference in traditional harvesting methods. Farmers always cut bamboo at a slanted angle using machetes. This not only helps prevent cracking, but also preserves the healthy base, allowing each bamboo clump to naturally regenerate within 6 to 12 months. However, this vigorous regenerative ability also has a downside. After many consecutive harvest cycles, bamboo absorbs nutrients from the soil very quickly, causing organic matter levels to drop by 25 to 40% after just 5 to 10 years of harvesting. What do you think are the best ways to solve this problem? Depending on terrain and farming practices, a skilled worker can harvest 400 to 600 bamboo stalks per day. Once cut, each bundle of bamboo is neatly stacked and transported manually or with small cranes to the forest edge, then loaded onto specialized trucks to be quickly delivered to the nearest processing plant, a zero-waste system where every bamboo stalk is reborn with a new purpose. After being brought to the receiving area, the fully loaded bamboo trucks are unloaded and sent directly to the primary processing zone. Here, workers quickly sort the bamboo according to diameter and maturity. Thick, solid culms are separated for use in construction materials or engineered plywood, while thinner and smaller ones are selected for straws and household products. Each stalk is then trimmed to remove roots and branches, and cut into shorter sections about 1 to 2 meters long to fit different production lines. In large-scale factories, automatic circular saws and conveyor systems have almost completely replaced manual cutting. These saw blades can process thousands of bamboo stalks per hour, producing sections with uniform length, clean edges, and an extremely low material loss rate. Next comes the node removal process, in which the inner joints of the bamboo are drilled or lathed off using automated deburring machines, creating smooth, hollow tubes ready for the next stages of processing. After being cut into sections, the bamboo is transferred to the washing line, a crucial stage that determines the quality and durability of the final product. Each piece first passes through large water tanks, rotary drums, or high-pressure water spray systems to remove mud, dust, and any remaining leaves or branches on the surface. For export-grade or food contact products such as straws, chopsticks, and spoons, the bamboo is soaked in hot water or a mild alkaline solution such as hydrogen peroxide or diluted baking soda for 4 to 8 hours. This step is extremely important as it sterilizes the bamboo, removes natural sugars and starch, the main causes of mold and insect infestation, while helping preserve its natural bright color. Then, the bamboo sections are placed into the boiling or steaming process, a crucial step that gives the material a lifespan of up to 15 years. Each batch is placed into stainless steel tanks or steam chambers, heated to high temperatures for 6 to 12 hours, depending on the thickness and moisture content of the culms. For premium bamboo cutting boards, after the carbonization process, the bamboo culms are split into thin strips and planed flat to create smooth, even surfaces. These strips are then coated with food-safe adhesive, typically formaldehyde-free resin or eco-friendly bio-based glue. Next, they are placed into a hydraulic press operating at pressures of 80 to 120 tons and high temperatures to bond the strips into solid panels. Once cooled, the bamboo sheets are trimmed, sanded, and polished to achieve a perfectly smooth finish. For premium bamboo straw products, only young, straight bamboo stalks with small diameters, typically 1 to 2 centimeters, free from cracks or insect damage, are selected. Next, each stalk is measured and cut to the standard length of 18 to 20 centimeters, then polished both inside and out using rotary sanding brushes to create a smooth, splinter-free surface that is safe for use. After sterilization and drying to reduce the moisture content to 10%, each straw is individually inspected, laser engraved with branding, and packaged in biodegradable paper sleeves or reusable fabric bags, ready to replace single-use plastic straws in cafes and restaurants around the world. However, natural bamboo straws currently account for only about 3 to 5% of the market, while bamboo fiber straws make up more than 20%, an industrially produced alternative that you'll see the manufacturing process of later in this video. On each bamboo board, hundreds of spoon and fork templates are pre-programmed into computer systems and precisely cut using laser beams or high-pressure water jets, ensuring smooth edges and consistent thickness. The cut bamboo blanks are then transferred to polishing machines, where their edges are rounded, surfaces are smoothed, and any sharp corners are removed. After being soaked in vegetable oil or coated with natural wax, the spoons and forks are tested for strength, heat resistance, and surface smoothness before being packaged and prepared for distribution to the market. The process begins by cutting the bamboo into blocks and shaping them into smooth rectangular handles using automatic molding machines. For premium models, CNC machines are used to create ergonomic curves or grooves that meet dental design standards. The most intricate stage is bristle installation. Tiny holes are precisely drilled into the toothbrush head, where biodegradable nylon 4 or plant-based bristles are securely anchored using micro stainless steel pins or natural adhesive. Finally, each toothbrush is polished again, inspected for smoothness, and packaged in recycled craft paper or biodegradable boxes, offering a sustainable alternative to plastic toothbrushes, combining durability, hygiene, and a modern, eco-friendly design. In modern factories, high-efficiency production lines can produce around 3,000 bamboo toothbrushes per day. But compared to more than 3.5 billion plastic toothbrushes consumed worldwide, that number is still very small. In the United States alone, over 35 million tons of plastic waste are generated each year, while eco-friendly products made from bamboo and other natural materials account for less than 5% of the market in the country. Could you explain the reason behind that? A more advanced version of bamboo material is strand-woven bamboo, a type of material made from bundles of bamboo fibers instead of whole culms or traditional strips. After being cut and carbonized, the bamboo is not split into strips but rather crushed or separated into long fibers, then dried and mixed with bio-based adhesive or heat-resistant resin to create bonding. When reaching the ideal moisture level, the fibers are evenly layered, each layer arranged in a different direction to enhance strength. These layers are then pressed in a high-temperature hydraulic press to form dense strand-woven bamboo blocks. Thanks to its fibrous structure, this material has mechanical strength up to 25% higher than oak or teak, while being almost completely resistant to cracking, bending, and moisture, with an average price of $1,900 to $2,000 per cubic meter. After cooling, the bamboo blocks are planed, cut, sanded, polished, and coated with natural oil or wax to protect the surface, giving them a service life of up to 25 years. Today, strand-woven bamboo is widely used in high-end furniture, industrial flooring, and sustainable architecture. The global bamboo materials market is currently valued over $70 billion USD, with laminated and strand-woven bamboo accounting for nearly 35% of the total value and growing steadily at over 10% per year. How are the surplus byproducts from production, such as bamboo dust, fine powder, and fibrous fragments left after cutting, turning, and polishing, fully utilized? The answer lies in bamboo powder technology, a breakthrough that transforms all bamboo waste into a new source of bio-based material. All remaining fragments and bamboo dust are collected, dried, and finely ground into powder, with particle sizes ranging from 80 to 120 microns. This powder is then mixed with other ingredients. The company does not disclose the details, but the formula includes cornstarch, minerals, and a biological adhesive they call bioadhesive. Yet behind this innovation lies a complex reality, where science, safety, and policy often collide. The formulas for composite bamboo materials vary among manufacturers, and not all are safe. Since 2022, the European Union has banned the import of food containers made from bamboo plastic composites due to concerns about toxic chemical leakage, especially when exposed to heat. From a broader perspective, even traditional plastic containers pose health risks, with evidence showing they can disrupt hormones and reduce fertility. Therefore, if bamboo-based products are certified safe and truly biodegradable, they have strong potential to become a sustainable alternative to plastic. When compared to paper, recycled paper remains the best option, with a carbon footprint only 1/3 that of paper made from bamboo or virgin wood, making it the most sustainable choice today. However, bamboo is still a valuable second-best option. Though not as efficient as recycled paper, it is far more eco-friendly than harvesting natural forests. Ultimately, even renewable resources like bamboo can have environmental impacts if overexploited. When managed responsibly, bamboo can offer great potential for the green economy, even though the price of eco-friendly products remains high. For example, at Walmart, a roll of real paper bamboo toilet paper costs $1.67, while a Charmin wood pulp roll costs about $1.25. Nevertheless, more and more consumers are willing to pay extra to support sustainable products. So, what do you think about the future of bamboo materials? Share your thoughts in the comments below. From the very first step, the salt is subjected to primary sorting, a task that demands the sharp eye and skilled hands of the workers. Only the pure, translucent pink crystals of uniform color are kept, while any blocks with impurities, deep cracks, or blotchy tones are immediately discarded. Alongside the precision of human craftsmanship, the mechanical power of automated conveyor systems plays a vital role. It is this combination that allows the production line to run almost without pause, with a processing capacity of up to hundreds of tons of salt each day. After sorting, the pink salt is immediately transferred to an automated washing system. Here, high-pressure water jets are sprayed continuously across the surface of the crystals, washing away fine dust and leftover fragments from the mining stage. Below, vibrating sieves shake relentlessly to remove remaining impurities, ensuring that no unwanted particles cling to the salt. Some may wonder, doesn't washing with water risk dissolving the salt? In fact, thanks to strict control of time and pressure, the water contact is just enough to clean the surface without affecting the solid blocks. Thanks to this cleansing step, the pink crystals emerge from the tanks with their signature shimmering hue intact, while reaching the purity required for the next stage of processing. From the washing tanks, the salt moves on to the stage considered the most powerful and dramatic: grinding. The raw salt blocks are fed into massive industrial crushers, where steel rollers weighing hundreds of kilograms slowly press down, breaking the blocks into smaller fragments. In some plants, jaw crushers are used instead, with two steel plates closing under pressures of dozens of tons, powerful enough to shatter a block of salt in just seconds. Once reduced to more manageable pieces, the salt is transferred to fine grinders. Here, blades spinning at over 3,000 revolutions per minute slice the fragments into uniform granules, producing the pristine pink crystals destined to become a refined seasoning on dining tables around the world. Once finely ground, the pink salt is fed into a sealed drying system. Inside, streams of hot air circulate continuously through each grain, gradually drawing out the remaining moisture. The temperature is kept steady at 90 to 100 degrees Celsius, just enough to ensure complete drying while preserving the natural crystal structure and the salt's signature rosy hue. Interestingly, once dried and passed through advanced optical scanners, Himalayan pink salt can preserve its quality for decades without the need for any additives or chemical preservatives. By contrast, ordinary table salt usually requires anti-caking agents such as calcium silicate or potassium ferrocyanide to prevent clumping, which makes it a product that has already been processed. This very distinction is what has earned pink salt its reputation as one of the purest salts in the world. Though praised as natural and pure, Himalayan pink salt can still contain trace amounts of heavy metals, such as lead, arsenic, or mercury. For this reason, every export batch must undergo strict testing to ensure consumer safety. In reality, the salt's signature pink hue is not the result of any miracle or mysterious property, but comes from the presence of iron oxide, Fe2O3, within the crystals. The very mineral that gives it its enchanting color and distinctive commercial value. The qualified batches of salt are immediately transferred to the semi-automated packaging area, where the entire process takes place in a sterile environment. The price of Himalayan pink salt is many times higher than that of ordinary table salt. In Pakistan, a bag of pink salt may cost only a few dollars, but once it reaches international markets, the price can soar 10 to 30 times higher, and even more for finely crafted artisanal products.